Pre-statistics. Make predictions with quadratic models. Less objectives. Use an equation of a quadratic model to make estimates and predictions. Number 2. Compute the x-intercepts of a quadratic equation using the graphing calculator. We'll do this both graphically and numerically. Less objective. We'll begin with the definition. A quadratic model is a quadratic function or its graph that describes the relationship between two quantities in a authentic situation. Let's do an example. Example 1. The annual revenues of the American Express are shown in the table for various years. Let R be the annual revenue in billions of dollars of the American Express in the year that is T years since 2000. So here we have our data. T is going to be 0, 1, 2, 3, and 4. And here we have the corresponding revenues for those given years. A model of the situation is f of t equals 2/3 t squared minus 4/3 t plus 23.7. We can see that this is a quadratic. It's got an x squared term. The degree is 2. Number 1. Use a graphing calculator to draw the graph of the model and, in the same viewing window, the scattergram of the data. Does the model fit the data well? Number 2. Predict the revenue in 2010. Number 3. Predict when the revenue will be 39.7 billion. Solution. The model of the situation is given by this quadratic function. So our first step is to put the data in our graphing calculator, graph it, and then put this model in the y equals and graph it. To put the data in the graphing calculator, I go to the stat, hit enter, put in the values of t for list 1, 0, 1, 2, 3, and 4. In list 2, put the corresponding dependent values, 23.7, 22.6, 23.8, 25.8, and 29.1. So now we want to do a stat plot. Second and y equals. My stat plot is off. Turn it on. I can hit enter. We can see now it's off. Hit enter to turn it on. The default is scatter plot. That's what we want. X list is list 1. Y list is list 2. That's correct. And then finally we need to hit zoom and number 9 for zoom stat. It would have been easier just to hit the number 9. So here we can see this does have somewhat of a quadratic pattern. Let's see how well the model fits our data. So I go to the y equals. I type in 2/3 x squared minus 4/3 x plus 23.7. Now hit graph. And we can see that this function is modeling the data very well. So this model is doing a good job of modeling this relationship. Number 2, to predict the revenue for 2010, we need to find what is f of 10, 10 years beyond 2000. So t is 10. To do this algebraically, I substitute a 10 in for t, perform the order of operations, square, then multiply, and then finally combine these three terms, and you should get 77.03. Now what does this mean in the terms of the problem? This means in 2010 the model says the revenue will be 77.03 billion. Since we have the function in our graphing calculator, we can let the graphing calculator compute this value for us, and let me show you how to do that. One way of doing it is using our table. If we go second and graph, which is table, and we want to go down to where x is equal to 10, and when x is 10, y1 is 77.033. Now there's another way we could do it. Let's exit out first. Since we have the model in y1, I can go to vars, which is short for variable, right arrow to yvars. Number 1 is function, that's what we want. And our model is in y1, so we hit 1 again. Then we do parentheses and we type in a 10. Close parentheses. Now this is telling the graphing calculator the input is 10 for the equation that's in y1. And when I hit enter, it will give the output. So you can do it algebraically, or you can let the graphing calculator compute it. And finally, number 3, so substituting 39.7 for f of t, we have this equation. One way of solving this is to subtract the 39.7 to both sides of the equation, where this is 0, and then we need to find the t-intercepts for this quadratic function. So if you recall, if y is 0 and you find the value of t, that is going to be a t-intercept. So the question is how do we find the t-intercepts for this quadratic function? Well, that's going to be the topic for our next video. It does turn out to be that t is equal to -4 and t is equal to 6. So in this example, we have two t-intercepts, one at -4 and one at 6. So in the terms of this problem, we would say the revenue was 39.7 billion in 1996. That's 4 years less than 2000. And in 2006, when t is 6, that corresponds to the year 2006. Thanks for watching.